At 5:40 a.m. local time, the first wave of Ukrainian-operated Beaver drones surged toward the Shahed assembly complex located just outside Danesk Airfield. To reach the target, however, they had to penetrate one of the densest air defense networks on the planet. Although Russian forces quickly locked onto the drones, that was precisely what the Ukrainian side wanted. 3 Beaver drones lifted off from a ravine northwest of Danesk and immediately drew fire from a nearby Russian Tor system. 5 kilometers away, 2 missiles launched from a tree line and streaked toward the lead drone. The operator dropped the Beaver to a mere 3 feet above the ground, threading it through drainage ditches while signal latency spiked past 300 milliseconds. The first missile attempted to track but could not handle the radical angle change and plowed into the dirt 65 feet to the left of the drone. Comment number 2 if you support Ukraine, number 3 if you support Russia, and number 4 if you love peace.
The second missile passed overhead and detonated close enough for the shockwave to jolt the operator's video feed for half a second. Behind, the 2 trailing Beaver drones fanned out, forcing the Tor to split its attention. All 3 drones remained airborne, but telemetry now revealed a more dangerous threat than missile lock, a slow, steady scanning pattern. This was the signature of the Russian Tor system, specifically designed to kill targets like the Beaver. Its radar did not need a clean visual lock. It merely detected the Doppler shift from the drone's propellers and steered missiles with course corrections every few hundred milliseconds. The lead Ukrainian operator knew this well, so he kept the drone razor close to the deck, where ground-reflected radar energy created false speed and position readings. Flying that low, however, burned battery life at an accelerated rate. Every meter of altitude surrendered translated into precious seconds of endurance they would need later.
The Tor crew panicked. Instead of waiting to reassess and relock, they ripple-fired all 6 remaining missiles in under 4 seconds, turning the horizon into a fireworks display of full salvo. This was exactly what the Ukrainian operators had hoped for. The Tor guides missiles via continuous command link updates, with the ground radar transmitting radio signals to make hundreds of tiny flight corrections per second. Yet the Tor data link can reliably talk to only 2 missiles simultaneously. When 8 missiles were fired in rapid succession, the final 6 received degraded commands, recycled target data, or no updates at all during critical seconds. Ukrainian operators had trained extensively for precisely this scenario.
All 3 Beaver drones suddenly climbed to 50 feet, not high enough to become easy targets, but sufficient to escape the ground clutter that was overwhelming the overloaded Tor guidance channels. Then they executed a counterintuitive maneuver, flying straight and level for exactly 2 seconds before dropping back down. Those 2 predictable seconds allowed the Tor fire control computer to generate an intercept solution, but the solution became useless the instant the drones descended. 2 missiles streaked into empty sky, 2 more slammed into the ground while trying to follow, and the final pair veered off, losing data link entirely and falling harmlessly into the void. The Tor was now Winchester and would require at least 9 minutes to reload. The Beaver drones pressed forward. The Tor crew was likely scrambling to reload while debating whether they had scored any hits as all 3 drones vanished back into ground clutter. The resulting chaos meant the Tor could not re-engage and had to hand off tracking to a larger system.
That larger system now came alive. A Buck M3 battery positioned 5 miles behind the Tor began sweeping the corridor with search pulses, not yet guiding missiles but building a picture of what was moving and where. Unlike the shoot-first Tor, the Buck took time to observe, tracking targets across multiple scans to learn their movement patterns. Ukrainian drone operators noticed the change because their data link degradation arrived in pulses rather than abruptly. Each scan meant the Buck was refining its track, preparing either to engage directly or to hand precise target data to the S-400 command post at the airfield.
The lead beaver dropped behind an abandoned gas station, while the operator checked battery status, 72% remaining and dropping faster than planned due to the extra maneuvering.
The second wave of FPV drones should have launched from forward positions to strike the tor before it could re-establish. Success would give the beaver drones a clear window. Failure would hand the buck clean tracking data and seal the corridor. Either way, forward movement was mandatory. Stopping meant certain destruction, yet flying straight ahead was exactly what the Russian buck wanted. The lead beaver left the gas station and flew directly into the buck's search pattern. The operator's signal indicators began to change, not the sudden spikes seen with the tor, but a steady pressure that made video compression increasingly difficult. The buck was taking its time, using its more powerful radar to track the drone even when masked by obstacles. Every few seconds, another full scan completed, and with each pass, the buck gained a clearer understanding of the beaver's trajectory.
The Ukrainian operator pushed his drone beneath a series of abandoned fuel pipelines, not to hide, since nothing could conceal it from such a powerful radar, but to disrupt the Buk's calculations. The Buk required stable velocity vectors to predict target position at missile impact. Every time the beaver flew at an oblique angle to the beam or abruptly changed speed, the Buk had to recompute. Those small errors accumulated, creating time gaps that could mean the difference between a direct hit and a near miss.
Behind the lead drone, the two trailing beaver drones faced their own difficulties. The second operator's latency climbed to 160 milliseconds, not from jamming, but from buck search pulses interfering with control packets. The onboard processor spent excessive time correcting the video stream, reducing bandwidth available for flight commands. The third beaver fared worse. Its operator could barely maintain a usable image through static. Then power lines appeared on screen. This was the opportunity they needed. The lead operator shoved the beaver directly beneath the lines, using steel towers and cables to create momentary radar shadows, brief periods when the radar could not see through metal.
For a large aircraft, this would be negligible, but for a drone the size of a large bird, every disruption mattered. The buck track quality degraded from solid to intermittent. Yet the buck did not operate alone. Somewhere farther back, the S-400 command post at Danesk Airfield had begun area scanning, attempting to make sense of the fragmented data it was receiving. The S-400 radar is built to track ballistic missiles and stealth aircraft at hundreds of kilometers. Asking it to follow beaver drones at treetop height was akin to using a telescope to hunt ants. But it did not need to track directly. It only needed to coordinate so that someone, somewhere, always had eyes on target.
The lead operator noticed his latency stabilize temporarily as the beaver cleared the worst of the Buk scan zone. Escaping lock, however, did not equal safety. The Buk would reacquire on the next sweep, and by then it would understand their heading far better. Simple math. Every kilometer closer to Danesk meant less reaction time. When missiles started flying again, the FPV drones needed to kill the tor immediately, or the entire mission would end before it truly began.
5 minutes after the beaver drones split, 6 Ukrainian FPV drones raced in from the northwest at 165 feet. Their operators had watched the tor crew frantically reloading, counting seconds since the last missile launch. A tor could fire again in roughly 90 seconds if undisturbed. The lead FPV dropped to grass-top height and accelerated straight toward the tor, while wingmen held higher altitude to split radar attention. The tor's computer could only handle so many targets moving in divergent directions before it began to error out. 2 FPVs might not suffice, but 6 flying entirely different profiles, high, low, fast, slow, straight, and weaving, turned the tor's targeting solution into chaos with incomplete intercept calculations.
The tor turret began slewing, trying to acquire the nearest threat. But each time it locked one FPV, two more appeared from different angles. The crew inside was likely shouting, attempting to manually override automatic target selection. It was too late. The first FPV slammed into the left side of the Tor precisely at the reload conveyor. The explosion ripped through thin armor. The second FPV struck the vulnerable under-turret area, where critical electronic cables converged. The turret froze mid-rotation and locked up as smoke poured from every seam. The Tor was destroyed, burning, and abandoned, completely combat ineffective. Celebration lasted exactly 3 seconds, because at that moment, the book reminded everyone it was still watching.
2 9M317 missiles launched from behind a tree line, rocket motors igniting the morning mist. These were not the agile short-range missiles of the Tor. Buk missiles are winged telephone poles designed to kill fighter jets at 25 miles. Using them against FPV drones was like swatting mosquitoes with a sledgehammer. But the Buk crew did not care about efficiency. They only wanted the Ukrainian drones kept away from their radar. The FPV operators saw the launch and did the only sensible thing, dropped to the deck and scattered. Buk missiles are very fast, reaching Mach 3, but optimized for predictable ballistic targets.
The first missile attempted to track a weaving Ukrainian beaver among abandoned buildings, could not handle the angular rate, and detonated early when its proximity fuse was confused by ground reflections. The second nearly succeeded, passing close enough for the shockwave to flip a beaver end over end, but the operator recovered control just before ground impact. 4 FPVs survived. 2 were heavily disrupted by nearby blast shockwaves and crashed, but 4 remained, enough for the next phase. The book had just revealed its exact position, and unlike the Tor, it could not reload quickly. A window to neutralize it had opened, but it would not stay open long. The S-400 had already adjusted its search pattern, trying to fill the gap left by the destroyed Tor.
The 4 surviving FPVs regrouped behind a collapsed building while operators calculated approach angles. The Buk M3 still had 4 missiles left. The lead FPV operator decided to fly straight in. The Buk crew expected the FPVs to use terrain for cover and attack by surprise. They did not anticipate a drone flying head-on like a missile. Sometimes the most reckless plan works because no one believes you will actually do it. All 4 Beaver drones went to maximum speed and formed a line-abreast formation, spaced roughly 165 feet apart. The Buk radar, mounted high on its mast to see over terrain, began tracking all 4 simultaneously. The problem for the crew was that they could not engage all of them.
They had to pick 1 or 2 targets and hope they chose the important ones, because intercept probability meant at least 1 beaver would get through. The Ukrainian lead operator, looking through his own drone, could even see the radar antenna beginning to focus the beam, likely locking his drone for engagement. That was when the third wave arrived from behind. 3 additional Ukrainian Beaver drones had circled wide around the engagement area, waiting for the Buk to commit. They attacked from the Buk's rear quarter, where the vehicle's own structure created a partial radar blind spot. The Buk crew had roughly 5 seconds to decide, deal with the head-on FPVs or swing the radar to face the rear threat. They could not handle both. They chose wrong. The radar began rotating toward the rear threat, meaning for about 2 seconds no one was tracking the frontal Beaver drones. The lead operator saw the opening and drove straight toward the radar array. The Buk crew realized the mistake and tried to swing the radar back, but the antenna does not move as quickly as a fighter jet's gun turret. It rotates deliberately and precisely because accuracy matters more than speed. The first FPV struck dead center on the radar face, punching through delicate transmit-receive modules and into the cooling system behind. The explosion was not massive. The FPV carried limited explosive, but it was sufficient. The radar panels folded like a broken umbrella, spitting sparks and flames as high-voltage cables shorted. The second FPV hit the radar mast base to guarantee the entire system would require full replacement rather than field repair. The book was now blind. It could still launch missiles, but without radar it was reduced to blind firing at last known coordinates and praying. The crew would likely abandon the vehicle within minutes rather than sit helpless. The Ukrainians made the decision for them when two more Beaver drones slammed into the crippled system. Yet Ukrainian operators were not celebrating yet. With the Tor and book down, the S-400 remained the sole guardian of the Shahed depot, and the S-400 is not easy to kill. It was built to survive the opening hours of World War III. The hardest part still lay ahead.
The S-400 command post at Junkoy Airfield was having the worst morning of its existence. The system is designed to track ballistic missiles at 250 miles, not drones cruising through an industrial zone at highway speed. Without Tor providing close-in defense and Buke handling medium-range threats, the S-400 operators had to do everything with equipment intended for entirely different purposes. Inside the 55K6 command vehicle, the crew cycled through every radar mode, trying to filter useful information from the clutter. The problem was their massive surveillance radar picked up everything: birds, highway vehicles, hot exhaust plumes from factory vents, and somewhere in that mess were the Ukrainian drones.
But which signal was the real threat, and which was merely morning traffic? The computers that normally classify this required data from other sensors that were now burning. Ukrainian operators knew the S-400 was struggling because their telemetry suddenly became smooth. No more radar spike peaks, no more interference patterns, just clean signals as if they were flying in peacetime. That meant the S-400 could not obtain high-quality track data for targeting. It saw something out there, but not precisely enough to waste a $40 million missile on it. That was when Ukraine played its trump card. A heavy Ukrainian Ram-2X glide bomb, essentially a camera-equipped flying bomb, had been circling at 6,500 feet for the past 20 minutes, well outside the main engagement zone.
Now, it dove not toward the S-400 launchers, but straight at the command post itself. The 55K6 vehicle is the brain of the entire battalion. Neutralize it, and the launchers become extremely expensive lawn ornaments. The S-400 radar finally obtained a clear lock as the glide bomb dropped below 1,650 feet. By then, however, geometry made interception impossible. S-400 missiles need distance to accelerate and maneuver. Trying to engage a target directly overhead is like punching someone who has already slipped past your reach. The crew likely had 15 seconds to evacuate. The glide bomb struck the roof of the command post, directly above the main processing area, housing all computers and communications gear.
The explosion was not Hollywood dramatic, no giant fireball, but the effects were immediate. Every screen went black, every radio fell silent. The entire S-400 battalion lost coordinated command in an instant. Individual launchers retained local control, but without the command vehicle designating targets, they were museum pieces. With the command vehicle destroyed, the S-400 launchers became easy prey as 3 remaining Beaver drones raced in toward them and their radar. The surviving Beaver operators, who had held position outside Danesk waiting for this moment, watched their mission clock turn green. The corridor was open. After 15 minutes of meticulously orchestrated destruction, every air defense node between them and the Shahed depot was either burning, blind, or brain dead. But the hardest part was not the fighting, it was what came next.
coordinating multiple drones through the same cleared corridor alongside dozens of other Ukrainian units without friendly fire incidents required Rolex-level precision. One mistake, and they would do Russia's job for it. Before any drone entered the sanitized corridor, Ukrainian commanders executed a rarely discussed measure: combat airspace deconfliction. The problem with success is that everyone wants to rush through the gap you just created. Without strict control, friendly drones collide, or operators jam each other by using overlapping frequencies. In this community, the phenomenon is known as blue on blue, and it has claimed more drones than some Russian air defense systems. To prevent it, the Ukrainians sliced the corridor into layers like a wedding cake.
Beaver drones held 165 to 330 feet. Any FPV in the area stayed below 65 feet, while glide bombs remained at 650 feet and above. No freelancing was permitted. You flew your assigned lane at your assigned time, or you did not fly at all. At 6 a.m. local time, the first Beaver crossed the commitment line into the Danesk Airfield zone. Through the camera, the operator could clearly see the Shahed Depot, a rectangular building with a curved roof, looking like any other military storage facility, except for the thermal signatures venting from its exhaust ports. Those signatures indicated internal activity. Either Shahed drones were being prepared for launch, or battery banks were charging. Either way, the end was near. The Beaver dove from 330 feet to 65 feet, accelerating as it descended.
Through the camera, the operator watched Russian soldiers sprinting between buildings, some pointing at the drone, a few raising rifles. Small arms fire was not a serious threat. Hitting an 80-kilometer-an-hour moving drone with an AK is like trying to hit a baseball with a toothpick. The real danger was the depot itself. If Ukrainian intelligence was correct about the contents, secondary explosions could sweep their own drones from the sky. The first Beaver struck the roof at a shallow angle, punched through thin metal, and detonated inside the main assembly area. The initial blast looked small, just a flash through a window, a puff of smoke. Then secondary explosions began, likely burning Shahed drones and fuel igniting like bombs.
The second and third Beaver drones were already inbound when the shockwave hit them. The second operator maintained control and drove his drone through a hole in the wall, adding payload to the inferno inside. The third Beaver was tumbled by the blast wave, recovered but could not find a path through the smoke and flames. The operator chose to strike an undamaged section of the building, ensuring total destruction. Comment number 2 if you support Ukraine, number 3 if you support Russia, and number 4 if you love peace.